If you've watched our other videos about how we write the equation of a rational function, there'll be no surprises in this. We're going to just do one more example the same way we've done the other problems. So I've gone ahead and provided my written description as 3 steps, A, B, and C, because this is the order I would do the problem in. If you weren't given this order, you could certainly do the problem in this order anyway. I begin the problems always by looking for my x-intercepts, or my zeros. This time I have 2 zeros. One of them's at 0 and one of them's at 4. The zeros determine what the numerator of your fraction is going to be, the numerator of your rational function. To get 0, I would just have an x by itself, and then to get 4, I would have x minus 4, because that, if I solve these, I'd get 4 and 0 as my 2 solutions. So there's the numerator. I can multiply that together if I wanted to, although I don't want to. Next up, I would move and I would find what the vertical asymptotes are. The vertical asymptotes will help me determine the denominator of my fraction. This time I've got a vertical asymptote at -3. And a vertical asymptote at 1. So to make that happen, I must have x plus 3, because solving, if I set that factor equal to 0 and solve it, I'd get -3 as a solution. And then if I want to get +1 as another vertical asymptote, I'd have x minus 1 as my other piece of the denominator. Because if I tried to plug in 1 or tried to plug in -3, I'd be dividing by 0, and I don't want that to happen. And then the final piece of this is to take a look at what our horizontal asymptote is. And this is the fine-tuning that sometimes we need to do. This time we have a horizontal asymptote, and it's located at y equals -2. Well, anytime, here's my note at the bottom, anytime your horizontal asymptote is y equals a non-zero number, in other words, we have an asymptote and it's not 0, we have to make sure that the degree of the numerator and denominator are equal. There's actually 2 things we need to check for. One is that we have to make them equal, and then that means we have to make sure our leading coefficients divide out to be -2. That's how we got these horizontal asymptotes. So if I check the degree, first of all, to see if there's any degrees I need to adjust, the degree of the top and bottom actually are equal. If I multiplied everything out, I'd have an exponent of 2 on the x. So they both do have the same degree, so that part's good. But now what I need to make sure happens is my leading coefficient needs to divide out to become -2. The easiest way to do that is to just do -2 over 1, and I don't even really need the 1 in the bottom, so just throw a -2 on the front. Because I have that, then I have equal degrees. I would then do that cover up and divide trick we've talked about, so I would basically ignore all this and see that 2 divided by 1 is just, or -2 divided by 1 is just -2. So let me just throw in f of x equals in front here, and then there's the equation of this rational function. I definitely want to graph this just to see if I'm right, to see if I missed anything. Do make sure if you're using your calculator, you need double parentheses, so I'll throw brackets around these, for the numerator and denominator, just to be on the safe side when you graph this. But you can check it and see that, yeah, this is definitely going to have all the characteristics we described. And then just a quick note about something you could do if you wanted to. I wouldn't do this, but you could if you wanted to. As long as my leading coefficient divides out to -2, I'm fine. So if I want to be weird, I could say that this is -8, and then throw a coefficient of 4 on the bottom. That would still get me the same description, the same horizontal asymptote, because if I divide these leading coefficients, I'd still come out with y equals -2 for the horizontal asymptote. Not that I would do that ever, but we could do it if we wanted to.